Hi guys, welcome to my first video. So today I'm gonna prove to you how to find the sum of the larger exponents of a and b by just knowing these information. Okay, so let's just start. Let's say if a squared plus b squared is equal to, let's just give like random value 12, and a plus b is equal to, say, 4. Okay, then how are you gonna find it? No, no. Let's say if it's AB. Let's give it more challenging. If AB is equal to -2. Okay. Let's erase this. Where's my eraser? Okay. So let's say just basically from this information, how are we gonna let's start with basic one. How are we gonna find a to the fourth plus b to the fourth? The first step is you have to find. Okay, so we just have to first organize it. So we know that a to the fourth plus b to the fourth is equal to a square plus b square times a square plus square. Let's just say square. And then we have to subtract out 2 times a square b square. Because if you do FOIL, then you will have a to the fourth plus b to the fourth. And if you do FOIL, you get this, but then you have extra part of 2 times a square b square, and you have to subtract it, right? You don't want this. Okay. So then what we get is, and then so first when we find a squared plus b squared, right? So we know that a squared plus b squared is equal to a plus b squared minus 2ab, right? So basically we can just plug in values for these. So we get 16 minus -4, which is 20, right? So we get that a squared plus b is equal to 20. So we just square it. And then you want to subtract this. Okay. So by the exponent property, we get that a squared plus b squared is basically just equal to ab squared, right? So it's basically just equal to -2 squared, which is 4, right? So it's just subtract 2 times 4, which is 400, subtract 8, which is equal to 392. This is a pretty simple one. Okay, let's look at a harder one. Let's look at a harder one, a more challenging one. Okay. Let me erase all of them. So next, let's say I want to find a to the fifth plus b to the fifth. That's kind of the same, okay? So basically, you just get the idea that, so for this, what you want to find is a squared plus b squared and a cube plus b cube. That's literally everything you have to find, okay? And then, since you know AB, what's AB? And then you have to subtract out. So then you just multiply these two, but then you have to subtract a squared b cubed plus b squared a cubed. That's what we have to subtract. So you just have to subtract this and subtract this. Okay. So basically, this looks kind of complicated because you only know AB, but you don't know. But this you can't just use the exponent property because they have different powers, right? So for this, you want to do. So first, let's start off. So we already know that this is 20, right? So how about let's find a cubed plus b cubed. So we just derive the formula. This is basically just equal to a plus b a squared minus ab plus b squared. So it basically just means a plus b times a squared plus b squared minus ab. So we just substitute out the values and we get 4 times 20 minus -2, right? Which is equal to 88. So this is just 88. So now the only thing we want to solve this is this tricky part. So we first multiply these and we get 1760. What we want to subtract? Okay, so for this what we want to derive is like something called a distributive property. So a squared b cubed plus b squared a cubed. Their common divisor is a squared b squared, right? So we can rewrite this as a squared b squared times a plus b, right? And then we can simplify this into 4 times 4, which is equal to 16. And now it's clear, right? So it's basically just 1760 minus 16, which is equal to 1744. Okay, that's simple, right? That's all. So now let's look at an even more challenging one. That's the last one, okay? So let's say if you want to solve a to the 7 plus b to the 7, the number gets larger, but actually this principle is exactly the same. So for this, okay, it's still a plus b is equal to 4, and ab is equal to -2, right? So a7 plus b7 is basically equal to a cubed plus b cubed times a to the 4th power plus b to the 4th power, and then we subtract a parentheses a cubed b to the 4th power times plus a to the 4th power b cubed, right? Okay, so basically we just want to find this. So this we already know is 88, and this I think we already solved it, right? What we get, I just erase everything, so I have to solve it again. So basically just equal to a squared plus b squared square, which is 20 squared 400, so it's 392. So we want to find this first, right? So this, we just do the multiplication. Which is 3, 4, 4, 9, 6. Hope I didn't make any mistake. So it's equal to 34499. But then we want to subtract this, right? So okay, so again, first we find a cube, b cube. Then we just want to do this, and that's all. That looks weird, but that's just what everything you have to do. Okay. So a cube, b cube is -8, right? So it's basically -8 times 4, which is -32. So this we subtract by -32, basically equal to plus 32, is equal to, bro, that's like ugly, which is just equal to 34,528. Thank you for watching. See you next time.